Okay, I think we can start now. Good afternoon, everybody. Okay, so last time I started to explain the LCD. Okay, as I explained before, I told you the LCD is connected this way. You have here PK0, PK1, and also we use port K, pin number 2 to 5 this way. Okay, so the LCD is connected to port K. Okay. Also, last time I explained in details several functions that can be used to use this LCD. The first function I explained, put character to LCD. So this function is used if you want to write a character, only one character, okay? And you have, before you call this function, you have to store the ASCII of this character in register A. After that, you call this function. This function is gonna display this character, okay, in the location of the cursor. For example, if the cursor is here, and then you want to display letter A, so you have to put the ASCII of A, which is 42, and then you have to call put character LCD. After that, you can see letter A here, okay? So this one is used for only one character. And as I told you before, any character you want to display, you have to store the ASCII of this character in register A. Even space, so you can, in chapter 2, there is a table for the ASCII codes of all characters, like space. Space has an ASCII, dot, a slash, plus, minus, equal. Everything has character, has ASCII. You have to use this ASCII. Also, last time I explained another function. We call this function command to LCD. This function is used if you wanna send a command to the LCD, okay? And what you have to do, you have to store the code of the command in register A before you call this function. And then I explain several commands we have. Every command has a code, right? So I explain this function. I explain the several commands we have here. So we have one command here, which the code is number one. This one can clear the display. We have another one here, which is number 2. This command returns the cursor to home position. Okay. We have also, I explained also last time, some of these commands you may not need much. Okay, for example, but or you may need it in some special cases, something like if you want to do some kind of rotating text, something like that, but it's not going to be in the basic use of the LCD. Okay, so for example, I explained about this one, I or D. So this one here, you want to move the cursor to the right or to the left. Okay, so if after every character you write, the cursor is decremented, means it moves to the left. For sure, in the initialization, I'm going to select it to move the cursor to the right. So that because I'm writing English, after I write letter H, I want the cursor to move from here to here. After I write letter E, I need the cursor to move here, this way, not this way. That's why in the initialization, I will select, I'm going to put one here, so that the cursor incremented, it's going to move this way. Okay, every time I write something, the cursor automatically is going to move to the next location. Some command is here, the cursor is off or the cursor is on. You can also make the cursor blinking. I'm not going to ask, maybe blinking is not a big deal, but you can, and also I think most of the time it's up to you if I make it on or off, but I think maybe you are going to make it on all the time. I think the initialization, I'm going to make the cursor on. On here means you can see the cursor, okay? For example, letter H and see a cursor this way. If it is off, the cursor is here, but you don't see it. So that if you write, you're going to write here, okay? But you don't see it. If I write, so I'm going to write here. If you write again, you're writing here, but there is no cursor. You cannot see it, okay? Also, I explained some instruction to turn here the display off. If you want to turn the display off, also if you want to turn the display on, okay. Also, I explained here some instructions. If you want to move the cursor to the right or move the cursor to the left. For example, if you have HELLO and the cursor is here, so we have some commands here to move the cursor to here or move the cursor to here. Okay, so we have commands to move the cursor to the left or if you want to move it to the right. Also here I explain some instruction to move to put the cursor anywhere. So here you have 16 character. And also here you have 16 character. So you can ask that I need the cursor here, I need the cursor here, I need the cursor here. You can ask it to be anywhere. However, I think, yes, you can do that. You can put it anywhere. However, I think we're going to focus only either here or here, okay? In the first line or the second line, okay? So here, if I want to write in the first line, so I have to put the cursor in the first line first. If you want to write in the second line, so I have to move to the second line. So I made it clear that if this is the first line, if you keep writing, it's not going to move automatically the next line. It's not going to do that. You have to write a command to move to the next line. And to do that, I already give you here these two commands here. So if you put C0, so C0 is going to put it at the beginning of line 2. So this is line 2. So it's going to put the cursor here. Okay. But this one, if you put 80, so 80 is going to move it to line 1. So we have, again, very simple. You have a table here. This table has a command, several commands. Last time I taught all these commands. For every command, you have a code. You have a code. You have to put this code in register A. If you wanna do any command, you have to put this code in register A, and then you have to call this function. Is that okay? So I told you guys for assembly we have only 4 functions. That's it. I explained the details. I have to explain everything. I cannot make it too simple and just teach 4 functions. Okay, and you don't understand the details. Okay, I don't think that's true. Okay, so I have to explain the details, how it works. However, all what I need from you for labs, for project, is to learn how can you use the functions. But I taught everything. Okay, so here actually in C, in assembly, we have only 4 functions. 1 function for configuration, and you have to use this one only 1 time in your program to do configuration. I didn't explain it yet, but I'm going to explain it right now. I already explained these 2, put character to LCD, command to LCD. Also, we have another one I'm going to explain right now. This one is called put string to LCD. You can tell from the English name, this one is used if you want to store a string, a complete message. But this one for only a character. But this one for a string. Yes. Because we have 16, shouldn't be more than 16. We have 16 in every line. We have 16 characters. Unless this is if you want to use it like the basic use of the LCD. But if you want to do something like rotating, that's a different story. But you cannot display anyway. You cannot display more than 16 in one line. 16 characters. Is that okay? So now I'm gonna teach. Before I move to C language, same thing in C language. We have a number of functions in C language. I'm going to teach these functions, okay, similar to what I did here, okay. But before I move to the C language, I wanna teach this function, configure LCD. I want to teach this one as well, and then I'm going to teach a program. How can we use the LCD using a program? So let's start with the configuration. So if you see this one again, this is just to do configuration. So as you see here, guys, number 1, I need to configure port key as output. Okay, so it's already here. And then here I make some delay. I have to wait some time because in order to configure the port input or output, it's going to take some time. That's why before I use it, I want to make sure the configuration is already done. Okay, because the circuit is going to make some time. That's why I put some delay here. Anyway, and then here, as you see here, guys, the way I'm going to do the configuration, I'm going to turn the display on. I'm going to turn the display on. I'm going to turn the cursor on. I'm going to turn the blanking off. There is no blanking. So all of these are done here in this instruction. So in this instruction, you turn the display on, cursor is on, turn off blinking. Also, you clear LCD. So here, what I do here, I clear the LCD. Also here, I ask the cursor to move to the right. Every time I read something, the cursor has to move to the right, which makes sense because we are writing English. So every time I write something, the cursor has to move this way to the right. So this one is done here. Okay. Also here, this is just a configuration. Here I'm saying here I configure the LCD itself. So the LCD here is 4-bit data LCD, and also it has two line display and 5x8 font. So every character should have 5x8. Okay. Anyway, so that's it. So this is what we have to do in the configuration. Any question, guys? So here I just, this is the, you have to call this one only one time, okay, before you use the LCD, only one time. Okay. Any questions? Okay, now let's move to the last one here. Put a string to LCD. Okay, and again, the good thing, guys, all these functions are already in the subroutines dot include. You got what I'm saying? So you don't need to worry about, you don't need to copy and paste. Just include the file and use, and then after that you can use all the subroutines I'm teaching in assembly language. Okay, so here put a string to LCD. So this one is used if you want to write a string, a message. Okay, so as you will see right now, guys, any message, for example, it's like hello, any message should have a number of characters. That's true. That is why inside this one, I'm going to use this one. I'm going to use put character inside it. Makes sense, right? So here, because all what I'm going to do, I'm going to get the first letter, and then I'm going to say put character LCD. Then I'm going to get the second letter. I'm going to say put character LCD. Get next letter, put. That's what should happen inside. That's what you will see right now. Inside, put a string to LCD. So here, and then I'm going to get next one. I'm going to get next one until I find the delimiter. You got what I'm saying? Until I find the delimiter. What is the delimiter? The delimiter is number 0. Okay, that is why you have to create a message this way. Look, guys, that's how you create the message. ECE 3130 is easy. Okay, so here you have ASCII for E, for C, for E, for space, and so on. And then at the end you have to put the delimiter, because what's going to happen is that for put string LCD, I'm going to give the beginning address to put string LCD. How we are going to give the beginning address of this of the string I want to display, which is letter E here. Okay, how I'm going to do that? I have to put it in register X. So put a string LCD. So before I call put string LCD, number one, guys, I have to write the message this way, and don't forget the delimiter. Okay, and don't put the delimiter inside here. Big difference, guys. Please don't make this simple mistake. If you put the 0 inside here, so what is the difference between this 0 and this 0? This 0 is going to be stored in ASCII, which is 30. You understand what I'm saying? So this 0 is going to be stored ASCII, which is 30. But this one is going to be number 0, right? Number 0. And again, as I told you before, if you want to use a delimiter, you have to make sure this delimiter will never happen inside here. Otherwise, if this delimiter happens inside here, once you find the delimiter, you are gonna stop. Okay. So how can I make sure of that? Simply because, and maybe that is why I selected number 0, because there is no ASCII for any letters that give you 0. So I am sure whatever you write here, nothing is going to have ASCII of 0. That's why I selected 0. You understand what I'm saying, guys? So I selected the delimiter so that I am sure this delimiter is not going to happen here. Okay. So anyway, so what I'm saying here, guys, as you see here, very simple. So number one, if you want to use put string LCD, all what you have to do, number one, you have to define a message this way. Okay. This is the message I want to display. Write whatever you want to write, but don't forget to put delimiter this way. This number one. Number two, before you call this function, you have to put the beginning address in register X, because this function is expecting the beginning address in register X. Is that okay, guys? So register X is here. What this function is going to do, it's going to fix this one. Are you 0? No, I'm not 0. Put character LCD, right? Then I'm going to increment X. Are you 0? No, I'm not 0. Then go to put character LCD. Go to next one. So I'm going to keep doing that for every character. I'm going to check if it's 0, I'm done. If it's not 0, then I'm going to fix this one. Put it in register A, and then I'm going to call both character LCD. Is that okay, guys? Any questions? Okay. So I'm gonna show as well. Again, I'm gonna teach right now how this function, how I program this function. But again, what's really very important is how can we use this function. In order to use this function, that's very easy. Okay. Again, all what you have to do in order to use this function, guys, is you have to create a message this way. You have to put a delimiter. Before you call this function, you have to put the beginning address in register A. That's it. And then this one is going to display from the location of the cursor. So if the cursor is here, so it's going to start from here. If the cursor is here, so it's going to start from here. If the cursor is here, it's going to start from here. So that's why you have to set the location of the cursor before you call this one. You understand what I'm saying? So that's what you will see right now. For example, I want to display something like what you see here, something like that. So I created two messages. This is one message here, and this is second message. I'm going to display this one in line 1. I'm going to display this one in line 2. Number 1, I'm going to do configuration. Only one time is enough. Once you do configuration, guys, what's going to happen? This configuration is going to put the cursor here automatically. This is a part of the configuration. It's going to clear. It's going to put the cursor here. Then after that, as you see here, I'm gonna write the first message. So the first message with this one here, I'm gonna write it here. Is that okay? Now I want to write the second message, but before you write the second message, you have to put the cursor here first, and that's what I did. So before I write the second message here, I have to move the cursor from here. I have to put it here. I have to move the cursor here. And once I do that, so I'm gonna write the second message here. Is that okay, guys? Easy, right? Do you have any question? How can you use string LCD? Before I'm gonna explain how I programmed it, but what's really important is how can you use it. So now in the coming lab, or if you want to display a message with the X, is that difficult? It's not difficult. Look here. Number 1, you have to do configuration here this way. Okay. Number 2, you have to make a message this way. Okay. Number 3, you have to use put a string LCD this way. And then if you want to move to the second line, you have to use this one. And then I'm going to write the second line. That's it. Any questions? Any question, guys? Okay. Now I'm going to teach how put a string LCD works. Okay. But as I told you the main idea. The main idea, X is here. Then I'm going to read this value. Are you 0? Yes. So I have to leave. No. So I'm going to call put character X. I have to keep doing it until I find the 0. Is that okay? That's exactly how it is programmed. So this is how we program this subroutine here, guys. Put a string LCD. Look how it is programmed. So number 1 here, as you see, number 1, I'm gonna read the location pointed by X, and then I'm gonna increment X, right? So this one, load register A 0, X, and then increment X. So it's gonna do both of them, increment X. Okay. But anyway, so this one is gonna read the location, it's going to read the byte here pointed by X. It's going to take this value, put it in register A. Is that okay? And then I'm going to see if this value is equal to 0, just done. I am done. Come here and leave. I'm done. Someone can ask me, what is compare? What is compare? That's okay. If you don't need compare actually, but if you want to put it here, I'm totally fine. You can say compare A to number 0. As I explained to you before, I'm totally fine if you want to put it, but actually you don't need it. Why? Because load, if you are loading a 0, this load is going to set the 0 flag. And this one is going to look at the 0 flag. So you don't need to use compare to set the 0 flag, because load is going to do that anyway. But if you are confused, you can put it. It's not a big deal. Okay. So number 1, guys, I'm going to read a location pointed by X, increment X. Also, I'm going to compare this one to 0. If it is 0, just leave. I'm done. If it is not, so I'm gonna call put character LCD to display this character, to display the character, and then I'm gonna go repeat again. So I'm gonna keep repeating this way. So I'm gonna keep repeating. Okay, I'm gonna keep repeating this part, guys. Every time I'm gonna read one character, and then I'm gonna call put character LCD until I find 0. Once I find 0, I'm gonna leave. Okay. Any questions? Okay, guys. Okay. By this way, I finished the assembly part. I hope you understand how can we use this functions. Any questions? Now I'm going to move to C language, and you are not going to see big difference. Just I'm going to change the names of the function. Everything is the same. Even the commands, the code for command is going to be the same code, right? So now I'm going to move to the C language. For C language, guys, we have a number of functions. I just want to teach this function, and then I'm going to show a program how can we use it. That's it, okay? So let's start with the first one. The first one here, LCD initialization. Initialization. This one is similar to configure LCD. So this one is the C version of configure LCD. You have to use it only one time in your program for configuration. Is that okay? Very easy. So this one is similar to this one. So similar to what you did here. I'm going to do the same thing for initialization, as you see here, using LCD initialization. Is that okay? So this is the first function. So similar to configure LCD, we have here one for configuration. This is number one. Number two, we have here also a function. It's called data 8 character. This one is similar to put character to LCD. Similar. So all what you have to, this one is used if you want to display one character. So similar to put character LCD, okay? But the difference is, in case of put character LCD, you have to store the ASCII of the character you want to display in register A, but here you have to put here, you have to send it as an argument here, okay? So whatever you want to display, you can just put it here as an argument. Is that okay, guys? Very easy. Just the same function. Same thing here, we have something we call instruction 8. This one is similar to command to LCD. Command to LCD. This one is used if you want to send the command, okay? But in case of command to LCD, you have to store the command in register A before you call this function. However, in instruction 8, you have to send it here. So you have to send the command here. Is that okay? Okay. Any questions? Just I want to compare with assembly to show you, to make it easy. This one is similar to this one, okay? So this one is similar to configure LCD. This one is similar to put character LCD. This one is similar to command to LCD. We have one more function, as you see here, guys, clear LCD. This one is used if you want to clear the LCD, okay? This one. Also, we have another one here. It's called hexadecimal to LCD. This one here, you just put here hexadecimal, and this function is going to convert the hexadecimal to ASCII and also display. So this function is going to do two things. So what you have to put here is just hexadecimal, right? From 0 to 50. That's all what you have to do, right? And then this function is going to take the number, the hexadecimal number, convert it to ASCII, okay, and then display. Okay. We have also a function. I taught this function before, guys. This function here. This function should convert hexadecimal to ASCII. So this function should return ASCII. So for example, if I give this function number 0, so this function should return 30, which is the ASCII of 0. If I give this function, for example, number 10, it should return 42, which is the ASCII of letter A. Okay, guys. So we have also a function. I already taught this function before. This function should take a number, a hexadecimal, and should return ASCII. Okay, guys. The other function I have here right now is this function here, type LCD. This one is similar to put string to LCD. Similar to put string LCD. So this one is used if you want to display a complete message. So how can we use this one? As you will see right now, you have to create array of characters this way, and then you have to send a pointer, the pointer here, for example, Q1, similar, or Q2. So I have to send just the name of the array of character, okay? And this one is gonna display it, okay? So I'm gonna teach it. I'm gonna show you the example now, but this one is similar to put string LCD. The last one I want to teach here, the last function I want to teach here is this one, set LCD address. This one is used if you want to put the cursor anywhere, okay? So you can put the cursor here, you put the cursor here, anywhere, okay? So how can you do that? As you see here, guys, you can use one of the commands I taught before. Don't be confused. By the way, I want to tell you something important here. Maybe some of you are going, for example, clear LCD. If you want to clear LCD, you can use this one, or you can use this one and you can put here 0, 1, 0, 1, number 1, because number 1 is the command for clear LCD. You got what I'm saying? So you can send it as a command, or you can use a function, this one or that one. Okay. So anyway, same thing here, guys. I already taught some commands in. By the way, this part is common. I know some of you are maybe confused here. This part about the commands, these commands are common between C and assembly. The same commands here, you can use it in C as well. So I taught a command here. You can put C0 if you want to put the cursor in the second line, or you can put 80 if you want to put it in the first line. So you can use these commands if you want. Or there is also another function also you can use. This function is called set LCD address. Okay. So, and then you have to put here a number where you want to put your cursor. For example, as you see here, guys, if you want to put the cursor here, I put 0, 0. If I want to put the cursor here, I put 0, 1, 0, 2, all the way until 0F. And then here I put 40, 41. So this is the number you have to put here. This is the number you have to put here. Is that okay? So again, this is another approach. So you don't be confused. You have two ways. Right? You have two ways to do it. If you want to put the cursor anywhere, one way you can use this function. Then if you want to put it here, I'm gonna put 0, 0 here. Or if I want to put here in the second line, this is the 16 and 16 character and 16 character. This is LCD, right? So I'm gonna use the second one. I'm gonna put the second 40 here. Okay. Or you can use the command here, and then you have to use the command, the code for the command that put the cursor anywhere, as I told before. Any question, guys? Yeah, sure. Can you read your voice? So with the LCD display only has 2 lines. It doesn't have like lines in that text to scroll down to replace the top 2 lines. Our LCD has only 2 lines. Every line can display 16 characters. Is that okay? If you wanna, that doesn't mean you can do like something. Okay, so if you wanna display like a longer text, how can you do that? I can make something like rotating text. Or if I want to make a menu, and it has several items. So for example, you can press a button. When you press a button, you can scroll down in the menu. You understand what I'm saying? But yes, at a certain time you can only display 2 lines. What if you have a menu? The menu has 4 lines. Okay, so I can display 2 lines. When I press a button, you can display the other 2, for example. Okay, or you can make it rotating something like that. But yes, the LCD can only display 16 and 16 in a certain time. Okay. Yes.
Why does the second line start at 40 instead?
I don't know. This is this is how they made the function this way. So they made this function so that when you put here 40, so this one is gonna you can see the first line. Okay. The first line is similar to the second line, but just here, this one has 0, this one has 4. Okay. There is no explanation for that, in my opinion. This is just how they made this function. You got what I'm saying? So now I'm gonna, any other questions? Okay. Now I'm gonna teach, or I'm gonna show you how I'm gonna use this function to display, to repeat the same program I taught right now in assembly. Okay. How can you display something like that? How can you do the same program? This program, how can you do it in C language? The same program I taught here in assembly. I'm going to teach how can you do it in. So if you see here, guys, it's very similar, very similar. Number 1, here I did configuration. Here I will do the same thing again. So if you see here, I did initialization, as you see here. This number 1. Number 2, here I have to create a message this way. 2 messages. Here the same thing. I'm going to create array of characters this way, array of characters. So this is what I'm going to display in the first line. This is what I'm going to display in the second line. Is that okay? And then here, I want to, for some reason, I want to start from location number 1, not 0. For some reason, I want to start from here. That's okay. If you want to start from here, you can put 0. You don't need to do anything, by the way, if you want to start from here, because when you do the initialization automatically is going to put it here. But anyway, for some reason, I want to start from here. That's why I'm gonna call this function. That's what I did here. Okay. After that, I wanna display the first message. So this is this one to display the first message. Then before you display the second message, you have to move to the next line. You have to move to line 2. In order to move to line 2, here I selected 41 instead of 40. I just want to put it here. So what I did here, yeah. So here as well. So okay. So you have to move to 41 before you call Q2. Before you send the second one. That's it. So once you do that, you are gonna see this message, the first message here, which is Q1 and line 1, and then you can see the second message here in line 2. Any question, guys? Okay, great. So now I'm done with the LCD. Very simple. Just to summarize what I said, very, very simple. If you want to learn how can you use the LCD, guys, you have to do the following. Number one, you should learn how can you use the 4 function in assembly. These 4 function, you should know how can you use them, and you can learn that from this example as I taught. This is number 1. Number 2, you need to know for the coming lab as well, and for the use of the LCD, you need to learn the commands here, all the different commands. Okay, very easy. Just you need to know if you want to do something, this is a code. If you want to do something, this is a code. If you want to do something, this is a code. That's it. Okay. For C language, all what we have here, again, we have only 4 functions, several functions, number of functions here. You should learn this function. You should know how can you use them, and already have a program here. Okay, guys, and you have the board. You have all these programs here. All these programs you have them in the. You don't need to copy and paste from the slides. You already have all these programs on the course website, so you can just run the program, and then you can learn by first you can run this program, and then you can change them if you want, so that you can learn. Yes. Yeah. This one makes initialization for the clock, because the clock has to be 24 megahertz, something like that. Always we put it in C language, okay, just to do initialization for the clock. So this one has nothing to do with LCD. No, it has nothing to. This one is LCD. This one we always do it. Okay, initialization only for the clock. Okay, any question, guys? Okay, now. Okay, so let me tell you what I did so far and what is left and what I'm gonna do. Okay, so in this chapter, guys, I already taught how can you use the LEDs. I already did that, right? Serial, how can you do something like serial communication? I already taught here I didn't teach yet how can you use the 7 segment. I will do that. I taught how can you use the buzzer, how can you make some sound. I already taught how can you use the switches, but I didn't teach yet how can you use the push button. We have push buttons here. I didn't teach the push buttons yet. Also here we have RGB. I already explained how can you use the RGB. I didn't explain the relay yet, so I will do that. I explained the keypad. Also, I explained the LCD. So also what is left here in this chapter is how can you convert binary to decimal, decimal to binary, because we need it. Okay, but before I teach these remaining topics, I want to move first to chapter 4. Okay, and then I'm gonna come back to here. The reason I want to move to chapter 4. Chapter 4 is about interrupts. Okay, because number 1, maybe most of you is gonna need it for group projects. Number 2, because we need it for the coming lab, not this lab, but the lab after this one. Okay, this week, as you know, this week's lab is about using the keypad and using the LCD. That's it. Okay, the lab after is gonna be about interrupts. Okay, so that's why I want to move first to chapter 4 here. Okay. In my opinion, this is one of the most important topics. Okay, I hope you understand it very well. Very, very important. And not only that, in my opinion, guys, if you ask me about the basics, the fundamentals, or the basics of microcontroller is chapter 1, 2, 3. 1, 2, 3 are the basics. In my opinion, starting from chapter 4 is advanced topics, and in my opinion, without in chapter 4, without interactions, you very simple. You cannot make big progress. Very simple. Say it again, please. I'm gonna say it again. Without interruptions, you cannot make big progress. Until now, we are making what I can say toy examples. Toy examples. Without interruptions, you cannot make big progress. What do you mean by toy example? I mean in chapter 3, I taught how can you make a buzzer, right? How can you make alarm of the buzzer, right? I'm not gonna buy a microcontroller, guys, is a computer. Microcontroller is a computer. It can do a lot of things, right? I'm not gonna buy it to make only a buzzer. No, I need to make like a big system. For example, you have a sensor. I can read the sensor. I can read the data. I can run the buzzer. I can take care of several things at the same time, and I can only do that using interrupts. Yes. We are going to use it for debugging. We're not going to use it for debugging. We're going to use it to write big programs. And you will understand what I mean exactly shortly after I start teaching. But for now, you should understand, guys, interrupts is a very important topic. I will do my best to explain it very well. I hope you understand it. There is no way. So look how many times, maybe this is the third, fourth time I repeat it. There is no way you can make a big programs. There is no way you make like a real system without interrupts. So I hope you understand what I mean by interrupts. Anyway, so in this chapter, guys, I'm gonna teach interrupts. Okay. So I'm gonna tell you what we mean by interrupt. So here, this is the way I divide it, you guys. Number one, I'm gonna explain definitions. I'm gonna teach you the concept of interrupt. What do you mean by interrupt? Okay. Then I'm gonna teach how can you program the interrupts. After that, I'm gonna teach two types of interrupts, very common two types. Actually, I'm gonna add the third one later, but I'm gonna teach here at least two types of interrupts. One is called IRQ, the other one is called RGI. Okay, so let's start with the details. Okay, so let's start. What is interrupt? Okay, until now, all what you need about all what you know about interrupt, you told me something very useful, very important. That's true. 100% you are going to use it in your capstone on if you want to make big projects. That's for sure. Okay, so let's start teaching the concept of interrupt. So this is the first part here. The first part I'm going to teach what is interrupt and why you are telling us it's very useful. I'm going to tell you here before I go to programming. So the first part here, there is no programming. So let's start with this one. This is the definition of interrupt. Look, let's read the definition word by word because every word is very important here. Let's read it. An interrupt is an event that requests the CPU to suspend the program execution briefly and run a subroutine. We call it interrupt service subroutine. Interrupt means an event. There is an event that requests the CPU to suspend the program execution briefly and run a subroutine. We call it interrupt service subroutine. Okay, just wait. I didn't explain what I mean by event, but at least now you got some words here are very important. Like you suspend the program. Event. This event is going to request the CPU suspend the program, execute a subroutine called interrupt subroutine, and then resume the program back or continue the program. Okay. So let me elaborate. Okay. So here, after executing the interrupt subroutine, the CPU resumes the program execution from the point it left the program. Okay. Let me give you more details now. Look here, guys. Let's see until now without interrupts. How can you execute a program like this one, guys? As I taught in chapter 1 to 3. As I taught in chapter 1 to 3. After we execute this instruction, we're going to move to this instruction. After we execute this instruction, I'm going to move to this one. After this one, we're going to move to this one. After this one, we're going to move to this one. After this one, we're going to move this one, and then we're going to move this one. That's what I explained so far, right? So all all what I'm gonna do, we're gonna execute one by one, instruction by instruction this way. Is that okay? This is not complete. This is true if there are no interrupts. After move, you are gonna move to next instruction. Okay, this is not complete. So this is true if there are no interrupts. So I mean, after this instruction, you are gonna come to this one. After this one, you are gonna come here. You are gonna come here. This is not complete. Okay, let me now give you a complete information. The complete information is, look here, guys. After we execute this instruction, if there is no interrupt, I'm gonna move to this instruction. If there is no interrupt, I'm gonna move to this instruction. Okay, after I finish this instruction, after I finish, not during, after I finish the instruction, if no interrupt, I'm gonna move to the next one. But if there is an interrupt, I'm gonna leave, I'm gonna suspend the main program to execute interrupt subroutine, and then I'm gonna come back to here. Okay, guys. So again, let me say it in a different way. What I did so far, I told you, after we execute an instruction, we're going to move to next instruction. We can move to next instruction. We can move to next instruction. Okay? That's not complete. What should happen is that after we execute an instruction, if no interrupt, I'm going to move to next one. No interrupt, I'm going to move to next one. If there is an interrupt, I'm going to suspend the program. Go run a subroutine, execute a subroutine related to this interrupt, and then I'm going to come back to continue again. So the way microprocessor works, guys, is the following. This is the way it works. After executing each interrupt, after executing every instruction, okay, either I move to the next instruction or I serve an interrupt. It's called serve an interrupt. So what do you mean? This is the expression. This is the term we are using it. And if you have an interrupt, okay, when I say I serve the interrupt, what it means? Serve the interrupt means I'm going to execute the subroutine of this interrupt. When I execute the subroutine of this interrupt, that's what I mean by we serve it. We serve it the interrupt. Okay, please wait. Just give me more time because the picture is going to be here now. Okay, I'm going to clarify point by point. So now what I'm saying here, guys, very important. This is how microcontroller works. After execute every instruction, okay, it's gonna check interrupts automatically. So after executing every instruction, automatically it's gonna check for interrupts. If there is an interrupt, it's gonna go, it's gonna execute serve the interrupt. Serve the interrupt, it means I'm gonna execute a subroutine of this interrupt, okay? And then after that, I'm gonna come back to the main program here. Okay. So if you see here, guys, is there a command here? Have you read a command to call a sub? So it looks like a subroutine. It looks like you go execute a subroutine and come back. So it's similar to calling a subroutine. That's true. That's true. It is similar to calling a subroutine. But there is a big difference between calling a subroutine and interrupt. When you call a subroutine, you have to write instruction to call the subroutine. Jump subroutine key value. Jump subroutine configure LCD. You can understand? So you have to write instruction here. You have to write instruction here to call a subroutine, right? But in case of, so there are some similarity. The similarity is you are going to go execute some code and come back. This is similarity between interrupt and between executing subroutines. Is that okay? This is the similarity. However, the difference is, in case of you want to call a subroutine, you have to write a command, jump subroutine. In case of interrupt, you don't write a command. This is done by the event, by the hardware. I'm gonna, for sure, I didn't tell you what I mean by event, but I'm gonna tell you what I mean. Okay, this is coming from the hardware. There is a hardware event. The hardware event, this is gonna be similar to jump subroutine. It's gonna call it. You know what I'm saying? So you can see here, guys, based on what I taught here, you can understand. Interrupt means there is an event. I didn't teach yet what I mean by event. It's coming. Okay, there is an event, and because of this event, the CPU is gonna suspend the program, go execute a subroutine, and then come back. Right? This event is coming from the hardware. I'm gonna give you more details. Okay. at least for now, you know, after execute one instruction, it's not guaranteed you are going to go to the next instruction, right? You are going to go after executing every instruction. I'm going to see if there is interrupt or not. If there is any interrupt, I'm going to go execute the subroutine and then come back, right? So that's why very important to learn is that we don't call a subroutine, nothing here. You see here any instruction to call a subroutine? No, we didn't call the subroutine, okay? So an interrupt means an event has occurred and a relevant action should be taken. A relevant action, and this action is written here in the subroutine. So event happened, an event happened, and I have to take action. And the action is written here. You have to write it here in the subroutine here of this interrupt. By the way, we have several sources of interrupts. Because it's not only one source. So we have here, for example, you have source 1, and source 1 has a subroutine. We have source 2. Source 2 has a subroutine. We have source 3, it has a subroutine, and so on. So if the interrupt comes from source 1, I'm going to execute the subroutine of source 1. If the interrupt comes from source 2, so I'm going to execute the subroutine of source 2, and so on. You understand what I'm saying? So it's not only one source. We have several sources. Any source of them can request interrupt. Okay. Any question? Yes. You have to program the interrupt source. You have to program. Okay, but now in this part, I'm not talking about programming. Okay, I'm gonna teach you later how can you program it. I will do that, right? But for now, I just want you to understand what is interrupt, how it is different from what we did before, why it is useful. That's what I want to do here in this part. Okay, then programming is coming. Okay, but at least just maybe I want to jump here several. Yeah, at least look how many interrupt sources we have. All of these are sources. So interrupt can come from IRQ, it can come from RTI, it can come from timer 01, timer 02. It can come from the serial communication 0, serial communication 1. By the way, serial communication 0, this is your code warrior. Code warrior, this is when you connect using the USB, so it's connected using this one, SCI0. Okay, serial communication. So it can trigger interrupt. That's why, as you will learn later, if you disable interrupts, if you turn off interrupts, code warrior is going to lose communication with your laptop because they're communicating with your microcontroller using SCCR. Anyway, so for sure I'm going to give you details, but just the purpose I want to show this one, guys. Just I want to tell you there are different sources of interrupts. I'm going to teach you for sure them in details. Every source has its own subroutine. Every source has its own subroutine. And if this one trigger or request interrupt, I'm gonna suspend the program, go execute the subroutine, and then come back. Okay. Anyway, let me complete. So step by step, you will understand what I want to say here. Okay. So again, event. There is an event, and because of this event, we have to suspend the program and run a subroutine. Very simple, just in 3 words. I'm explaining interrupts in 3 words. Event, suspend the program, run a subroutine. 3 words. Event, suspend the program, execute the subroutine. That's it. Okay. So an event, okay, an event can be a signal coming from a device, just a sensor or circuit or timer, whatever. Okay. For example, so this is a microcontroller. The microcontroller has external pin. That's what we call it, IRQ. Okay. Here I want you to understand what I mean by event. You told us the whole story starts by an event. Yes, it starts with an event. So event, request interrupt, and then suspend the program, execute a subroutine. That's true. Okay. So now, what do you mean by event? There are different types of events. One event I'm explaining right now, we have an external pin. This is external pin is connected to a sensor, a circuit, whatever. Every time there is a falling edge here on the external pin, this is an event, trigger interrupt. Again, there are different types of events. Here I'm explaining only one type of events. Okay, the event here means there is a falling edge on the pin. You have a pin, there is a falling edge of the pin. That's the meaning of an event in this case, right? So every time there is a falling edge on this pin, this is in case of IRQ. Again, I'm going to say it again. We have, I'm explaining only one type of events. There are different types of events. I'm going to explain later. But just to understand, this is just one type of event here. Every time there is a falling edge on this pin, okay? So here I'm asking the microcontroller to suspend executing this program and then execute a subroutine, okay? For sure, the subroutine has to do something related to this event. Related to this event, okay? Here I'm giving you an example to understand it better. For example, if you have here a train, you have a sensor here. This sensor is connected to IRQ, where every time the train is coming, the sensor should generate a signal like this one on the pin, external pin here. And this is the event. This is the event. So every time the train is coming, there is a signal. Every time the train is coming, this is the event, right? So the event means the train is coming. This is the event, right? So the event, the train is coming. So, and because of this event, there is a falling edge here. Because of this falling edge, you are going to trigger interrupt, IRQ interrupt. This is one type of interrupt, IRQ interrupt. And then the microcontroller is going to suspend the main program and go execute a subroutine. Okay. So now the question is, what should I write here in the subroutine? What should I write? Okay. I have to write something related to the event. The train is coming. So I have to write in the subroutine, you have a gate. You have a gate here. You have to lower the gate. Okay, so I have to lower the gate this way in order to prevent the car from crossing the railway. Okay, the tracks. Any questions? So yes, that's how it is. So every time there is an event, like for example a falling edge here, your CPU is going to suspend executing the program, and you are going to run a subroutine. Usually here in the subroutine, I have to write something to respond to the event. To respond to, like for example, if you have a gate here, so I have to lower the gate. That's what I have to do. Okay. So here this signal is going to request interrupt from the microcontroller to lower the gate. The term you are using, guys. So now you should understand. We have what we call interrupt request, and we have a term serve the interrupt. Interrupt request. You are requesting the interrupt, right? You request by the event. Every time there is a signal this way, this is the event. So the event is going to request the interrupt. When I execute the subroutine of this interrupt, now I serve the interrupt. What I'm saying. Similar, if you want to interrupt, now I'm teaching the lecture. If you want to interrupt me, what would you do? Raise your hand, right? So when you raise your hand, you are going to interrupt me, right? Raising your hand is an event. So now I'm going to stop. I'm going to suspend my teaching to the lecture, and now I'm going to serve the interrupt. You got the main idea? Yes. Okay. Okay. And again, I don't call this one. So this is, yes, it's a subroutine. It's similar to executing a subroutine, but here, look, here is the program. I'm not going to write jump subroutine. I'm not going to write it. And this is the part that confuses most of the students. Most of the students who don't understand interrupts are usually confused. How you are going to execute the subroutine? I didn't write an instruction to call it. You don't call the subroutine, right? This is something done by the microcontroller, by the hardware, not by you. You are not going to say jump subroutine. No. Okay, what's going to happen? The event is going to trigger the microcontroller, the hardware. Microcontroller automatically, hardware is going to suspend executing the program. Is going to go to the subroutine execute, right? Okay. Now, so far, I think I hope you understand the concept, the idea of interrupts. Okay. What I didn't explain it yet, how it is useful. You are telling us this is something great. You are telling us you cannot make a big program without interrupts. You can't, right? This is very important. That's what you told us. But you didn't tell us how it is useful. I'm going to tell you how it is useful. But before I tell you how it is useful, anyone still doesn't understand the idea, the concept here, There is an event, hardware event, right? Suspend the program, execute a subroutine. You don't write an instruction to execute the subroutine. The calling, you don't call the subroutine. The calling is the subroutine is done by the hardware, by the event. Okay, any question, guys? And usually, not usually, always, what you have to write in the subroutine, it has to be something related to the event. I give you one example here. The event in this case, the train is coming. So I have to write in the subroutine my response, reaction to this event. Right? So now, okay, tell us how this one is great, why it is very useful. I'm going to tell you why it is very useful. Okay. Number one, better utilization of the CPU. Better utilization of the CPU. That means I can write big applications. Okay, guys. CPU is a computer. CPU is powerful. CPU can do many things at the same time. What I explained in chapter, very important. What I explained in chapter 3, how can you do only one task? Chapter 3, flashing. So all the times the CPU is going to do flashing, only one task, right? CPU can do multiple tasks at the same time. CPU is very powerful, okay, because of the interrupts. That's what I'm going to teach right now. Okay. For example, without interrupts, CPU execute commands so that for here I'm just giving you one example to understand how interrupts can make better utilization of CPU. Okay, I want you to understand very well. Number one, to make a delay. You remember in chapter 3 we made a delay. Delay Y miss. Okay, delay Y miss. Okay, the way we did it in chapter 3 in delay Y miss, CPU execute some commands so that the total execution time equal to the delay. That's what we did in chapter 3. You have push ball. You remember the delay Y miss when I executed chapter 3? Push ball. It doesn't do anything. You just push and ball. You push and ball. You just want to waste time. If you want to make a delay for 1 second, CPU is going to execute some instructions. They actually they don't do anything other than just wasting time, right? That's what we did. Okay, so without interrupts, CPU executes some commands all the time. Okay, this is wasting of the CPU capability. Why? Because the CPU is busy in counting for the time. So what if you have a sensor? What if you have a fire alarm? What if you want to do something? Because this is a system, guys. CPU is a system. You can do many things at the same time. If the CPU is already busy just to count for 1 second, I can't use it for something else. What if you want it at the same time? If you want to use the keypad and you want to use the LCD at the same time, how I can do that? You can say. That is why this is without interrupts. So without interrupts, that's what we did in chapter 3. Okay, I just used the CPU, which is a computer. I just used it just to count for 1 second, right? This is waste of the capability of the CPU. Okay, is there a better way to do it? Yes, using interrupts. And here you should understand why interrupts are very beautiful. Okay, why are very useful. You understand it right now. Okay, for example, if I have an external timer, hardware timer, this timer should count for Y millisecond. And after counting for Y millisecond, it can interrupt me. So for example, it's going to make one interrupt every Y millisecond. That means the CPU does not need to count. CPU does not need to count for 1 millisecond as we did in chapter 3. Who's going to do it? An external circuit. So that the CPU is going to be free. All what I need, every 1 millisecond, for example, as we did in chapter 3, I want to do flashing. So every 1 second, turn on, turn off, turn on, turn off. Is that okay? So if I want to do the same thing right now, all what I'm going to do, guys, I'm going to ask the timer here to interrupt every 1 second. So here, 1 second, 1 second, 1 second here. On all what I'm going to write in the subroutine, I'm going to write in the subroutine flip LED. Because now this subroutine is going to be called every 1 second. Every 1 second, I'm going to call the subroutine. Every 1 second, I'm going to call the subroutine. And in the subroutine, I'm going to say flip LED. How much time did you take from the CPU? Nothing. Just nanosecond. Why nanosecond? Just the time to execute a subroutine. Just a few nanoseconds. That's it. Okay. But now the CPU is free. So here, this is the main point. Here, the CPU is free. It can do something else. It can take care of sensor. It can look at the fire alarm. It can control the buzzer. It can control the keypad, other things. Okay, very important. Okay, sorry, let me finish this example and then I'm going to take question because very important to understand it. Okay, so here let me complete the example here before I take questions. For example, if I ask you, I want to write a program to do flashing of LED. I want to turn it off for 1 second, off for 1 second. And also at the same time, I want to read a value from the keypad and display it on the LCD. Okay? So I want to do flashing, and at the same time, I want to read a keypad, put it in LCD. Without interrupt, you can't do that. Without interrupt, you can only do one task, which is, for example, flashing. Because I have to turn an LED on. Then the CPU has to count for 1 second. Then I have to turn it off. Now the CPU has to count for 1 second, keep looping. I don't have any time remaining to do the LCD and the keypad. CPU is busy 100% of the time just to do flashing. That's why I can't do anything else. That's why without interrupts. However, if I make it with interrupts, look here, guys. Now in the main program, I can write the code for keypad and LCD. And now I can ask the timer, please, timer, interrupt me every 1 second. So every 1 second, I'm going to leave this pen, go, flip the LED, and then come back. Every 1 second, go, do this one, and come back. And because you are doing it very fast, you are not going to feel that the program here is suspended. You are not going to feel. All what you are going to see, everything is running smoothly. Nothing is suspended because it's doing very fast. By this way, I can run 2 tests at the same time. This is for 1 interrupt. What if I use 5 interrupts? So now I can run 6 tests at the same time because every interrupt can do 1 test and the main program can do 1 test. Beautiful. So very, very beautiful, right? So now, if for example, if you use 10 interrupts, so that means I can run 11 tasks at the same time. Every interrupt is going to take care of 1 task, and the main program is going to take care of it. That's why I'm telling you, very important. Yes.
So the computer can only do 1 task at a given time.
That's true. Please say it again and read your voice.
The computer can only do 1 task at a given point.
That's true. Only for the Zoom students. So I want to tell them. Computer can only do 1 task at a given time. That's totally true. I agree. Yes.
So couldn't we do that without interrupts if we put it within a while bit? Check for
I like the way you are thinking. Okay, so you are thinking, okay, I'm not gonna do interrupts. Okay, I can do it using programming, right? The answer is no. Why? Simply because you have to count for 1 second. You have to write comments to count for 1 second. But here I don't count for 1 second because I have external timer who's gonna do the work. Yes.
Do we know how many cycles to give that?
I don't know because even sometimes it's too complicated, too difficult. You can't because when you call the keypad, you are gonna it's a keypad subroutine is gonna stay there until you enter some value, right? So you don't know how long it's gonna be too difficult, too complicated. And you are talking about 1 test, one interrupt. What if I have 10 interrupts? It's gonna be more. So I like the way because this is the way you should understand it. Okay, I like the way you want to do it without the idea of interrupts. No, it's not gonna work. Right? I want to tell you something before we continue. By the way, and there is something I'm not sure if you are for sure. I'm sure you have heard something like that. We call it multitasking. I'm sure all of you should heard something about multitasking in computers because that's exactly what we are doing right now. So we have something we call it multitasking. Multitasking means that's what we do in our computer. That means you may have a song, you run a song, you play a song, and also maybe you are using a word, you are writing word. Maybe also you are using C program, you are running a C program. You are running all these different programs at the same time, right? That's what we call multitasking. You can do several things. That's what we do, right? In our computer, you can run a song at the same time. You can Skype, you can run Skype, you can different programs at the same time. However, again, I'm talking about the basic computer, because you know there are now, we have multi-core, we have something very advanced, but the basic idea here is that how can we do multitasking? Okay, as you said, that's why I focused or I stressed too much on what you said. Microcontroller can only execute one program at a time. Microcontroller can only execute one program at a time, as you said. Okay, so what happens is that I'm gonna run only song for a little bit time, and these two are off, right? And then, for example, this one for 10 milliseconds, for example, very short period of time. And then after that, I'm gonna run this one. I'm gonna turn these two off for 10 milliseconds. Then I'm gonna run this one, and this one is off for 10 milliseconds. And then I'm gonna come back, repeat again. So I'm gonna go back, repeat again. And this is the main point. Listen to me. So at a certain time, I'm running only one program at a certain time, right? But short period of time, and then I repeat, right? So the trick or the trick here is, or the main point here is, microprocessor is super fast. Because the microprocessor is super fast, you are not gonna feel that your phone is boost or suspended. You are not gonna feel it. You are gonna feel like everything is running at the same time, which is not true. But because you are doing it very fast. If you do it very slow, you are gonna start to feel. Okay, the program is not responsive. It's not responding well. You are gonna see some break. You are gonna see some break. The song is breaking. Okay, you are gonna start to feel it, right? That is why what I'm saying, and this is a very interesting thing, guys. Our microcontroller, yes, you can run several tests at the same time. You can do several things using interrupts at the same time. Is that okay? However, we have limited resources. I cannot run 1 billion tests at the same time. I can't do that because the performance is going to be too low. You understand what I'm saying? So what happens if you have too many things to do, right? So that means by the time you come here, it's going to be too much time to come back to here. Okay, which means you start to feel it's breaking. Okay, so what I'm saying, guys, you should understand is what I'm saying using interrupts. Okay, let me clarify it here. Okay, so now, and this is how our program will be from now on. Our program will be different, guys. From now on, our program will be different. What we have done so far, we have the main program. That's what we have done in chapter 1, 2, 3. Only the main program. In the main program, you have some part here. I think I called it main program before, and then you have subroutines, right? All of this now is called the main program. Here, I'm gonna run only one task. Okay. Now I have subroutine 1, subroutine 2, subroutine 3, subroutine 4. This way, for example. Now this one is running task 2. We have task 1, task 3, task 4, task 5. So now I have in total, I have 5 tasks in total, right? In the main program, I run one task. Every time there is an interrupt here, I go execute, come back, go execute, come back, go execute and come back, go execute and come back. There is a condition here. The condition is if everything you run fast, you are not gonna feel there is suspension. There is no suspension. Okay, everything is running at the same time. So this is a very important thing. You understand what I'm saying? So you have to make sure everything is running quickly. That is why the more interrupts you put here, the more interrupts you make here and put here, for sure you are gonna start the performance of your system is gonna be great. That's for sure. Because we don't do magic. we have a limited resources. You get what I'm saying? So that's why, yes, if you use too many interrupts, more than the competition capability, it's gonna work, but you are gonna start, the program is not responding. When you press the button, it's a keypad. When you press the keypad, it doesn't display at the same time. It takes, there is some delay. Why is it? Because the keypad was suspended and it was doing something else. But again, if you do it very quickly, right? So it should be okay. You can run many things at the same time. Any questions? Okay. So I'm sorry. I'm going to give you another example still to understand. So again, the purpose of this section, guys, in this section, I want you to understand, number one, what is interrupt, how it is different from what we did before, why it is important, why you cannot make programs without interrupts. That's what I'm explaining here. Is that okay? I have another example here, guys, just also to understand how interrupts are very useful. Okay, in this example, if you wanna detect events, okay, for example, without using interrupts, for example, you have here, guys, I wanna repeat the same example here. You have a train is coming, you have a sensor. Every time a train comes, you are gonna generate a signal like this one on the pin here. Okay, if you don't use interrupts, can I do it? Yes, you can do it. But the CPU is gonna do only one task, right? So how can you do it without interrupts? That's what we call polling. Polling means to avoid missing an event. An event here means the train is coming, means to avoid missing a pulse. The CPU must continuously read the sensor pin. So I have always to check this pin, right? The CPU cannot do anything else. Otherwise, if you don't check the pin and you do anything else, you may miss this event. Okay, so you cannot do anything else. Okay, that's what we call polling. So polling, if I want to see if the pin is coming or not, all of them, this is the pin. I'm gonna read the pin. Okay, are you one? No. Are you one? No. So I'm gonna make a while loop, right? So pin. So the CPU is gonna be busy all the time, right? It cannot do anything else. That's not good, because what we said for interrupts, we have to run several tests. This is only one test. Okay, so instead of doing that, what I can do here, I can use interrupts so that the interrupt circuit, the hardware, will notify the CPU when the event comes. Okay, so polling, you actually wasting the processor resources in checking infrequent but important events. Very important. What I'm writing is very important. Polling, the idea of polling means, as I explained here, polling means you continuously check the pin. I want to see if there is an event or not. So I'm going to make while loop to continuously check the pin. That's what we call polling. So polling, you are going to waste the resources in checking infrequent but important events, right? So I just want to give you another to understand it again here in another example. If you don't have interrupts, guys, so I'm going to do only one task, as you see here, only one task. So what I'm going to do, if the sensor pin is 1, lower the gate. So I have to keep it checking here. Okay, if you don't check at any moment, maybe you are gonna miss an event, which is very dangerous for sure. So I have to keep doing this way. So the CPU is doing only one task. For sure, that's not good. If you want to use interrupts, what's gonna happen? I can put here a task. This task, you can use the keypad, you can use the LCD, you can take care of anything else. You can do a task here, and then every time there is an event, the hardware is gonna trigger interrupt, then execute this one and come back. So very important. Please listen to this one. Very important. So because of interrupts, I'm not gonna waste my time to check for the event. I'm not gonna do that because it's done automatically by the hardware. CPU, I'm not gonna take any time from the CPU to check the pin to see if there is an event or not. The CPU is gonna do one test here. And once the event comes, the hardware is going to trigger interrupt, and CPU is going to leave this test and go execute this one to save the time of the CPU of checking the effect. Yes. Say it again. Interrupt.
Is that interrupt tied to the clock? It's like it's your microcontroller checking it every time on the clock, or is it
Hardware. This is hardware. I don't need to write a command in the software. This is a hardware. This is check is done by the hardware, right? It's not by the CPU. Hardware. Okay. So yeah. So that's what I said in the very beginning. After you execute any instruction, okay, hardware will take me here or take me here. You got what I'm saying? But I don't need to write here an instruction to check if it is one or not. Hardware will do that, right? Any questions? Very important, guys, to understand it before I here in this part. I'm going to talk about programming. How can you program it and how can you use it in application? You will see if you compare what I did in chapter 3 in flashing LED, it's going to be too simple now, because all what I'm going to do, I'm going to just initialize, or I'm going to program the timer. I'm going to tell the timer, please timer, interrupt me every 1 second. That's it. So I'm going to write some instructions to program the timer. Okay, please timer interrupt me every 1 second. And that's it. Then every 1 second, I'm going to just write one command, flip LED. That's it. So if you compare how I'm going to do flashing now with what I did in chapter 3, it will be much easier now. Okay. Any question before I move forward, guys? So let me summarize what I said before I move forward. Number 1, guys, I told you we have several sources of interrupt, not only one source. Several sources of interrupt. This number 1. Number 2, for any interrupt, when there is an event, this event requests the CPU to suspend the program and go execute a subroutine and come back. So number 1, we have several sources of interrupts. Every source has a subroutine, right? And automatically the program, the CPU is gonna suspend the program. Oh, 16. Okay. Just give me one. I just want to wrap up what I did here. So here the CPU is gonna suspend this one, go execute a subroutine, and just come back here. Okay. Very important. I said it 3-4 times. I'm not gonna write a command here to call. This is similar if when you call a subroutine, but big difference. When you call a subroutine, you have to write a command to call a subroutine. Here, this is coming from an event. Also, you should understand what I explained, how you are gonna jump, how your program will be from now on. From now on, your program can have. By the way, don't be confused. In the last lab, we have 3 tests, but we didn't run them at the same time. At a given time, we ran only 1 test, but we changed it from 1 test to another. Listen to me, okay? So in the last lab, don't be confused between what I did on the last lab and this lab. And this topic. Here in this topic, you can run 3 different tests at the same time. But we didn't do that in the last lab. In the last lab, at a given time, you ran only 1 test. Okay? So you should understand this idea. Your program is not going to be written in one place anymore. You have 1 task in program 1, 1 task in interrupt 1, interrupt 2, interrupt 3, interrupt 4, and so on. Every one of them is going to take care of one thing. The buzzer, the buzzer is task 1 is going to do it, or interrupt 1 is going to take care of it. If you want to use the 7 segment, task 2 is going to take care of it. If you want to use the LCD and the keypad, all of them at the same time, the main program can take care of it, and so on. Very beautiful. Okay. And I explained here. Very important. So next time I'm going to teach how can you program the different interrupts. But again, you should understand why they are useful. Why using interrupts, I can run several tasks at the same time. Very important. This I'm going to repeat it again. Sorry, guys, for just. Okay. So just I want to see this one again because it's very important, guys. What I'm saying here, you should understand why using interrupts I can execute multiple tasks at the same time. You got what I'm saying? Just because of the interrupt. But again, you should understand, I don't have unlimited resources. At a certain point, if you have too many interrupts, at a certain point, you are going to feel like the performance is low performance, right? It's going to be the program is not responding. You press the button, but it's going to take you have to press 3-4 times until you see until you see it in the LCD, right? That's why yes, it's okay. I can run multiple tests, but for sure there is some limits there. Okay. Okay, guys. Also, I give you some examples to understand how using interrupts I can do two things at the same time. That's what I didn't do in chapter, or this is what I can't do in chapter 3 without interrupts. I can't do it. Also, I give you another example. I think that's a very fair. I spent much time to explain what's interrupt because it's very important to understand it, because programming is easy. I'm going to teach what you have to do to program it. It should be easy, but the concept itself, you should understand the concept very well. Okay, guys, see you next time.